And joining us now in studio, Harry Kondratas with Kondratas Kissel Consulting, Inc. Nice to have you here, Harry. Should we establish off the top, your last television appearance was when?
1962.
1962. So you just make it a habit of doing these every 40 years, whether you need to or not?
Basically.
Okay. Harry, I want to start by reading something that was in Time magazine back in March of this year. It goes like this. Until recently, natural gas was the forgotten stepsister of fuels. It provides about a quarter of U.S. electricity and heats over 60 million American homes, but it's always been limited, more expensive than dirty coal, dirtier than nuclear or renewables. Much of Europe depends on gas for heating and some electricity, but the bulk of the supply comes from Russia, which hasn't hesitated to use energy as a form of political blackmail. The fuels of the future were going to be solar, wind, and nuclear. Natural gas is up now, way up, and it's changing how we think about energy throughout the world. Let's start there. What's changed?
We've seen some innovations in the ability to get natural gas out of the ground. One of the big ones, which I believe to be a game changer, is the ability to extract shale gas at fairly high quantities.
What's shale gas?
Shale gas basically is natural gas. You'll see it embedded in sedimentary rocks. Shale is an example, formed millions of years ago. Shale by nature has very low porosities. If you just drill basically small holes in it that allow the gas to escape. It's very difficult to get the gas out if you just drill a hole into it, as you would with conventional drilling. But if you were to basically be able to go into it horizontally along the plains of the shale and be able to fracture it, you generate huge amounts of surface area that allow the gas to be released.
Fracturing it means?
Basically breaking the rock apart along its plains.
And the industry has somehow figured out a way to do this more economically. It
has taken a while. Interestingly enough, first examples of fracture stimulation in the U.S. were done in 1949. George Mitchell, who in the 80s had Mitchell Energy, worked on being able to develop shale gas from the Barnett deposit. I think he worked on it for about 10 years. They finally did figure it out and were able to commercialize it.
I think we got some video here. Michael Smith, our director, can you roll this video? Harry, look at the monitor over my shoulder here and just talk us through this if you would. What are we looking at here? We're
drilling right now through various layers of rock. You can see the drill head right there. Now with directional drilling, you're able to go sideways into the shale deposit. You're right now basically it looks like you've moved the perf gun into place. It's gone off. You've generated basically holes in the casing. And now you've fractured it with water that you've introduced into the well, along with sand particles, and they may have used some polymers as well in that. That process that you see there, you've generated huge amounts of surface area with all those cracks. You can now release the gas.
Takes a lot of water though, yes?
It does. For the Barnett shales, I believe, the numbers I recall, were somewhere around 3 million gallons to do the entire frac for the number of stages they went through.
So does that make it, never mind economical, but is that a good use of our water supply?
Well, they do basically are able to collect the water back and recycle it, reuse it again. Yeah, it is a concern. There are some areas where you basically are deficient in water, and that's something you have to be cognizant of.
Where do we have shale gas in Canada?
Biggest deposits we have in Canada are in the Montney, which is between British Columbia and Alberta, and also in Horn River. Fairly big. Those are both fairly big deposits. And a relatively new one that they've been developing now, the Utica Shale field, which is in the Quebec lowlands. The Montney and Horn River, they've been able to frack it. They've figured it out. These are producing areas right now. Utica, they're still working on it. I believe they've been able to get some of the wells to go beyond 1 million cubic feet a day, but more work is required to be able to figure that one out.
I need to get a better sense of that, because of course if we're talking oil, you talk about barrels, and people got a sense about how you measure oil by the barrel. How do you measure natural gas?
Natural gas, the best measure given the sheer quantities are what we call TCF, which is trillion cubic feet. You know, for example, the total amount of gas in Canada right now that we found, both shale and conventional, is around 450 TCF. And out of that, I believe somewhere around 388 TCF are basically as shale gas. and what we call tight gas.
And of course, again, if we're talking oil, you'd say this is enough to power so many cars on the highway for so many years. How would you measure it similarly with natural gas?
There's a conversion which you would do, which barrels of oil equivalent, and you do it on a heating basis, and I believe it basically is a ratio like 6-to-1 between natural gas and oil.
More natural gas than oil?
Yeah, basically on it.
6-to-1?
6-to-1 on it. You go by basically, well, now we're getting a bit technical, but if you're looking at in terms of BTU content and in terms of pricing, it should be about 6-to-1. What it does reveal to you is natural gas pricing here in North America is cheap. It's cheap compared to what crude oil is going for. And primarily because they've been able to find these large quantities of shale gas. We've seen all energy commodities go up, except basically natural gas. And that has sort of been creeping along at somewhere around $5 per million BTU when you go by US pricing.
At current rates of consumption, how long would the known global reserves of shale gas last us?
Oh, global reserves. We're still finding shale gas in some countries. China, basically, I believe, they may have come across something like about 1,200 TCF. That's a hard one to define. I can give you numbers for North America.
Sure,
in the United States, I believe it's over 100 years at current consumption rates for natural gas. In Canada, it's somewhere beyond 150 years at current consumption raits.
So we got lots.
We do have lots of it, and in fact, I saw a recent commercial from ExxonMobil where they basically stated that fact, that we have so much of it available.
Let me go back to that original quote from Time magazine and ask this question that emerges from that. How do you think this new knowledge, this new ability to explore it, to get it out of the ground, how should that change how we regard solar, wind, and nuclear?
I'd look at basically natural gas as a bridge fuel. It takes care of what we need in the immediate. We are working towards better energy sources out there. I'm sure the next generation of nuclear reactors that that we're going to be developing will be certainly a lot more safer and not create sort of problems as we've seen recently. Similarly, for solar and for wind, those energy sources, my biggest issue with them is the price. I mean, technically they work. They're just expensive. Natural gas will allow you to basically be able to power your needs and carry forward until such time as you've come up with better solar panels and better reactor designs. And who knows what else we come up with in the next 20 to 30 years.
I hear you, but of course what they love about solar and wind is that it doesn't create a lot of pollution, Harry. How about natural gas? How about shale gas?
Well, with shale gas, let's put it this way, you get a lot less from that than you would from coal firing. A typical combined cycle plant, you can get efficiencies up to 60% on these coal-fired plants. I believe Nanticoke is still running. You're somewhere around 30 to 35%. Also, you get less carbon dioxide just from the fact you're burning that methane that's got hydrogen in it. So it does help in terms of efficiencies, in terms of just putting less greenhouse gases in the air. It doesn't eliminate it.
Right. It's not
but
as
it
clean.
does give us the time until we get to that point, when we get something truly better at a reasonable price.
When renewables are easier to do and cheaper to do is what you're saying.
That's right.
Okay, let me try this on then. Michael, can we do this one, bottom of page 2? This is from ProPublica, published a couple of years ago, but still relevant to read. Get comfortable, takes a while. Norma Fiorentino's drinking water well was a time bomb. For weeks, workers in her small northeastern Pennsylvania town had been plumbing natural gas deposits from a drilling rig a few hundred yards away. They cracked the earth and pumped in fluids to force the gas out. Somehow, stray gas worked into tiny crevices in the rock, leaking upward into the aquifer and slipping quietly into Fiorentino's well. Then, according to the state's working theory, a motorized pump turned on in her well house, flicked a spark, and caused a New Year's morning blast that tossed aside a concrete slab weighing several thousand pounds. Fiorentino wasn't home at the time, so it's difficult to know exactly what happened, but afterward, state officials found methane, the largest component of natural gas, in her drinking water. If the fumes that built up in her well house had collected in her basement, the explosion could have killed her. Obviously, this raises questions about risk. Every technology's got risk. How much are we prepared to put up with, though?
Well, that particular example, when we saw that video segment we ran earlier on with the drilling, one of the segments that it showed the drill going through was an aquifer. After that, we basically cased the well. Possibly what may have happened here is when they were drilling this, they didn't case the well properly.
Casing the well means?
Casing, you're basically getting steel piping putting down in there, and then you run concrete through it as well to make sure that when you're carrying the gas to the surface, it doesn't leak out into rock formations above or into aquifers. That's one possibility. But bear in mind, the Pennsylvania case is rather, how you say, a bit unusual, because that's out of the Marcellus Shale. You almost had like a gold rush out there for shale gas when the whole thing got going. I've seen pictures, one of them was quite famous, and it was in National Geographic, where you saw this drilling operation being carried out on the farmer's pasture. When you get things going too fast, sometimes even the regulatory structure isn't catching up to it. As an example, on the other end would be in Alberta, where they do have specific regulatory requirements. If you're working in an agricultural area, you're supposed to be so far away from aquifers and such, and you're supposed to follow procedures to ensure that you're not going to basically be disrupting someone's farm effort.
But as I said, everything's got risk, and if you're going to compare the risks of drilling for this compared to the risks of what it takes to build a nuclear power plant or the risks of building a coal-fired generating station, how would you compare them all?
Well, you're always going to have that risk there. We can't build perfect aircraft. We can't build perfect bridges. The problem is you drill several shale gas wells, and you could be drilling hundreds of them. All you need is for one to go wrong, and you've got a problem. So that's something we have to sort of weigh against with other energy sources. Nuclear, the risk on that one is self-evident from 3 Mile Island through Chernobyl and Fukushima.
Let's read another piece. This one's from the New York Times from a few months ago, and it's about that fracking that you told us about a moment ago. Michael, if you would. Hydrofracking carries significant environmental risks. It involves injecting huge amounts of water mixed with sand and chemicals at high pressures to break up rock formations and release the gas. With hydrofracking, a well can produce over 1 million gallons of wastewater that is often laced with highly corrosive salts, carcinogens like benzene, and radioactive elements like radium, all of which occur naturally thousands of feet underground. Other carcinogenic materials can be added to the wastewater by the chemicals used in the hydrofracking itself. Okay, once again, we get back to how safe is all this. Here's an example of somebody who seems to think, well, as reported in the New York Times a few months ago, where it's not as safe as it ought to be.
No,
is that a concern?
You make efforts to capture it. Again, I think a lot of what went on earlier on, a lot of the regulatory structure wasn't in place. And guys will do basically what they can get away with on it. When you have proper regulatory structures in place, you look after the wastewater. No, you don't dump it back into a creek or something like that. You capture it, you clean it up, and you restore it to the state it was when you basically got it out of the ground or from whatever source you got it from.
The good players do that. The good players do that.
Yes, it does. Well, basically all the players have to go through and do that. This is a big money business. It's really not one for very junior companies to get into, ones that could sort of skimp on costs and all that. And the ones that I know of basically follow regulatory structures and good practices on it, because there's a good business to be made in this thing. You don't want to go and do stuff like this. But I know in the case of Pennsylvania earlier on, it got pretty frantic there when people were trying to sign up all these farmers. And for a farmer that basically gets a lease option on their land, it's like they won the lottery. They were glad as can be to get that stuff.
Having said that, can fracking be made safer?
It can. You basically make sure you capture all these materials, don't let them get back into nature, and also sort of respect sort of where you are working in. You know, if you're going into a whole sort of agricultural area on it, you may have to sort of get consensus of everyone in that area before you start doing things, rather than just getting the consensus of the one farmer that you happen to make the deal with.
But presumably recapturing, for example, the wastewater is expensive. And people who want to cut corners will not...
No, you don't. You just go and do it. You just go through and do it. It's the regulatory practice. You can generate enough money out of this shale gas itself that will cover all these expenses. There's no need to do that type of practice. And I frown on any company that would do that.
Okay, in our last couple of minutes here, let's talk about the future. And I want to get a better understanding of how you see shale gas figuring into the mix of energy uses that we currently do. You know, in Ontario now, we're practically, 50% reliant on nuclear. Do you see shale gas, since it is more economical and easier to get to now, replacing how much of that? Half of that? Well, 20% of that?
It potentially could, but if you look at the current government's energy plan going forward, natural gas does not figure prominently in there.
It does not, no.
Mind you now, nuclear did figure prominently until we saw some of the bids come back for the reactor they're proposing in Darlington. Now we have to do a rethink on everything.
Yeah.
It does provide a means, as I call it, a bridge fuel. If you need a power plant built, you need it built within 2 years, this is how you can do it. You can get the private sector to build it, not having to go through government and having taxpayers to pay for the whole thing.
That's tough, easier said than done, though. You know, they tried to do that in Oakville, and of course the public stormed up in reaction, and the provincial government canceled it.
Yeah, that one was rather interesting, although there's others that, very interesting. I mean, the first big plant I worked on was Lake Superior Power in Sault Ste. Marie, and I didn't see anywhere near the reaction that we've seen of recent. I think the fact that when you start building these plants near large population centers, you do get people's attention on it. Funny thing with Portland's, originally when it went forward, it was pretty quiet, yes. And then later on, especially near the mayoralty race, all of a sudden everybody got on board and found reasons why it shouldn't be built. It's always a difficulty when you've got power plants near urban areas. It'd be ideal if you can build them far away from everything, but the problem is we're getting urban sprawl literally everywhere.
I mean, you're obviously sold on the potential of shale gas, but as far as, say, powering our cars, you think it could be useful for that?
Absolutely. I'll give you an example. Dean T. Boone Pickens in the U.S. has been a very big proponent of basically using all this natural gas they have available to literally convert the entire truck fleet of the United States to run on natural gas. Now think of how much you can clean up the environment in that respect by getting all that diesel fuel out. And also, you become less hostage literally to global oil pricing.
I was going to say, you'll make a lot of Middle Eastern dictators very unhappy if you do that.
Yeah,
You're okay with that, I guess.
I'm okay with that.
Okay. Harry Kondratas from Kondratas Kissel Consulting, Inc. on shale gas. Thanks so much for coming in tonight.
Thank you.
Nice to have you here.